Good morning.
Good morning.
Today we are going to make our semester 3 exam review worksheet in mathematics. Are you all ready?
Yes.
The lessons covered for semester 3 exams are the remarkable identities, how we factorize an algebraic expression, the trapezoid with the mid-segment theorem in a triangle and a trapezoid, how we solve equations of the form ax plus b into bx plus c equals to 0, how can we solve a first degree inequality in one unknown, and the last lesson is about the Pythagorean theorem. Read question number 1, Selena, please.
Indicate whether the following statements are true or false.
We should indicate whether which one of the following statements is true or false. The first one.
X cubed is a common factor among the terms 2x cubed minus x to the power 4 plus 3x squared.
If we have this algebraic expression, Hassan, if we have this algebraic expression, what is the common factor between these terms? X squared, because the common factor should be a variable with the least exponent. So is x cubed a common factor?
False.
This is the first one is false. Yes, Ala.
In an isosceles trapezoid, the non-polar sides are true.
When we have an isosceles trapezoid, the legs or the non-parallel sides are equal. Yes, this is true. Yes, Dana.
The equation 2x into 4x minus 7 is equal to 0 has two solutions. True.
This equation has two solutions. Yes. The first solution is 2x equal to 0. We solve it. 4x minus 7 is equal to 0 and we solve it. Yes, Ali.
If A great is A smaller than B, then A minus C is greater than B minus C. False.
This is false because if we have A less than B, an equation in this form, if we add or subtract the same number from both sides, the sign is preserved. If we multiply by a negative number both sides or divide by a negative number, the sign is reversed. So this is false. Yes, Hassan.
4x squared minus 5 equal 2x minus 5 into 2x minus 5. False.
This is false. How can we factorize it, Hassan? Can you tell me? We have two terms. So this is a squared minus b squared equal a minus b into a plus b. So factorizes
2x minus radical 5.
yes into 2x plus radical 5. Yes, right, Hassan. Yes, Badia.
The triangle EFG is right at G, then EF squared equal EG squared plus AG squared 2.
This is true. What do we call this here, Badia? Pythagorean theorem. If you can see down, never forget the three remarkable identities in this worksheet are very important. A squared plus 2ab plus b squared equal a plus b all of it squared. A squared minus 2ab plus b squared equal a minus b all of it squared. A squared minus b squared is equal to a minus b into a plus b. Now, question number 2, we are given two algebraic expressions, p of x and q of x. The first thing we should do here is to expand, reduce, and order p of x and q of x. Okay? Who can tell me if I have an algebraic expression, to expand this algebraic expression or to develop it, what should we do?
Get rid of the parentheses.
We should all know that we should get rid of parentheses. This is the expanding of an algebraic expression. Yes, Dana. Let's expand p of x. First, in p of x, we have two parentheses multiplied together. Multiply them, Dana. 2x times x. 2x squared. Plus 2x times plus 3.
Plus 6x.
Plus 6x. Then we multiply minus 1 by x.
Minus x.
Is minus x. Minus 1 by 3.
Minus 3.
Minus 3 plus x squared goes down minus 9. Now we should see if we can, after expanding, we should see if we can reduce. Yes.
2x plus x squared.
We reduce like terms or similar monomials. 2x squared with x squared
3x squared.
is 3x squared. Yes, also 6x with minus x
Plus 5x.
plus 5x minus 3 minus 9.
Minus 12.
This is p of x. Now, Badia, please reduce q of x.
X squared
This is done, reduced. It is,
x squared
yes,
plus 6x
yes.
plus 9
Now, minus 2 is multiplied by the second parenthesis. Minus 2x times minus 3
plus 6x
plus 6x minus 2x minus x
plus 2x squared.
plus 2x squared. Now, let's reduce like terms, Badia.
X squared plus 2x squared equals 3x squared.
3x squared
Plus 6x plus 6x equals plus 12x.
plus 12x
Plus 9 equals 10.
plus 9 goes down. So these are the expanded p of x and the q of x. Now we continue. We should solve p of x is equal to 0. Who can tell me to solve p of x? What should we do? Yes, Ala? We must factorize Muhammad p of x, okay? So p of x, who can give me again p of x, please?
2x minus 1
2x minus 1
into x plus 3
into x plus 3
plus x squared minus 9.
plus x squared minus 9. Yes, Ala. If you look at p of x, let's look at the first two binomials. Do we have anything? No. Let's look at the second part of the equation. What do you have? Remarkable identity of x squared minus 9. Which remarkable identity? The last one, which is a squared minus b squared. So we write the first as they are, 2x minus 1 into x plus 3. Yes, Ala, plus?
Into x minus 3.
Yes.
Into x plus 3.
X plus 3. Now what do we have common factor? X plus 3. Yes, this is equal to 0. X plus 3, big parenthesis,
Into 2x minus 1.
into 2x minus 1 plus, yes, is equal to 0. So x plus 3,
Into 2x minus 1
yes,
plus x minus 3.
is equal to 0.
X plus 3 into 3x minus 4.
3x minus 4 is equal to 0. Now look at this form. We have two parentheses multiplied together. So how many solutions do we have? The first solution is x plus 3 is equal to 0. Then always the solution we put it in a
Box.
the second one,
3x minus 4 equal to 0.
yes,
3x equal 4.
3x is equal to 4.
X equal 4.
This is the second solution. Now we should solve q of x is equal to 0. Yes, Selena, what is q of x?
X squared
X squared,
plus 6x
yes,
plus 9
plus 9
minus 2x
minus 2x
into minus 3 minus x.
minus 3 minus x. What do you have, Selena, here?
Remarkable identity.
Which remarkable identity? The first one, which is?
X plus 3 all of it squared
Don't forget to write the squared.
plus
Minus 2x into minus 3 minus x. If you look at these two terms, do you see a common? What do you have here? The second one looks like the first. How can I make it the same? We take a minus common, okay? So this is equal to 0. Then we write x plus 3 squared. We take a minus outside. It becomes plus 2x into x plus 3 is equal to 0. Now what do we have common?
x plus 3.
X plus 3. We will have,
X plus 3
yes,
plus 2x.
right, is equal to 0. So x plus 3
into x plus 3 plus 2x is equal to 0. X plus 3
Yes.
into 3x plus 3
3x plus 3 is equal to 0. How many solutions do we have?
2.
X plus 3 is equal to 0, then x is
to
equal.
minus 3.
This is the first solution.
3x plus 3 is equal to 0.
Yes.
3x is equal to minus 3. X is equal to minus 3 over 3. X is equal to minus 1.
This is the second solution. Okay? Any question? Any question?
No.
Now we should solve P of x is equal to Q of x. To solve P of x is equal to Q of x, do we repeat from the beginning?
No.
What do we take? The factorized P of x and the factorized Q of x. So this is the factorized P of x. Do you see it?
Yes.
And this is the factorized Q of x. We only take these two, okay? So we write, what do we write, Ali?
X plus 3
Into 3x minus 4 is equal to,
x plus 3 into 3x plus 3.
what do we do here, Ali?
We take
The second part
first
to the first part and we write it as,
x plus 3,
yes.
3x plus 3.
Now what do you have common?
We have x plus 3 common.
Yes, x plus 3 is a common factor.
3x minus 4 we keep in parentheses.
3x minus 4
Minus 3x plus 3
is equal to 0.
x plus 3 x minus
3x minus 4 minus 3x minus 3 is equal to 0.
x plus 3 equal 3x and minus
3x minus 3x they cancel, we will have minus 7 is equal to 0. Here how do we write it? Minus 7 into x plus 3 is equal to 0. Can you tell me, Dana, in this equation how many solutions do you have?
We have 2 solutions.
What are the two? How many variables do we have? 1. Minus 7, is it equal to 0?
No.
We don't take it. What do we take only?
Plus 3.
We only take x plus 3 is equal to 0, then x is equal to?
Minus 3.
It only has one solution. Do you get this?
Yes.
Okay. Now we should solve P of x is equal to 3 of x. What do you think we should take here? The expanded or the factorized P of x? The expanded P of x. What's the expanded P of x?
3x squared.
Who can give me the answer of the
3x
expanded P
squared.
of x? It is
3x squared
3x squared,
plus 5x
yes,
minus 12
is equal to 3x squared. Now we get the 3x squared to the first part of the equation. It becomes minus 3x squared is equal to 0. 3x squared minus 3x squared, they cancel each other. We will have 5x minus 12 is equal to 0. We solve it. 5x is equal to 12. X is equal to 12 over 5. This is the solution. Okay?
Yes.
Now we should solve Q of x is equal to 9. Who can give me the expanded Q of x? Yes, Dana, give me the expanded Q of x, please.
3x squared.
It is
3x squared.
the expanded Q of x.
3x squared
3x squared
plus 12x
plus 12x
plus 9
plus 9 is equal to 9. Now we get it to the first part. So 3x squared plus 12x plus 9 minus 9 is equal to 0. 3x squared minus 9 plus 9, they cancel each other. Plus 12x is equal to 0. What do we take common?
X.
Between 3x, we take 3x. 3x into x plus 4 is equal to 0. How many solutions do we have?
2 solutions.
2 solutions. We have 3x is equal to 0, then x is equal to 0, not minus 3, okay? Or x plus 4 is equal to 0, then x is equal to minus 4. This is the second solution. Now we should find P of minus 1 and the Q of 0. To find P of minus 1, what do we take?
Expanded form.
We substitute in the expanded form. In 3x squared, what is 3x squared plus 5x minus 12, right?
Yes.
So we
Substitute.
minus 1 squared
Plus 5 into
plus
minus
5
1
into minus 1
minus 12.
minus 12 equal
3 into 1
3 into 1
Plus
minus 5
minus
minus
12
12 is equal 3 minus
minus
5 minus
minus
12. 3 minus 5
minus 2
minus 12
minus 14.
minus 14. Now we should find q of 0. We substitute also in the
Expanded form.
which is
3 into
3
0
into
all
0
squared
squared
plus 12 into 0
plus 12 into 0
9.
plus 9. Now 3
3
times
into
0
0
plus 0 plus 9 equals 0 plus 0 plus 9 equals 9. Any question? Now question number 3, we should solve equations and inequations. The first equation, always before solving any equation Badia, before solving any equation, it should be factorized, okay? To factorize an equation, either we look for remarkable identities or like terms. Here we have 3 parts in this equation. This is a part, this is a part, and this is a part. In the first part, what do you see?
6 commas.
What do you see? We see, before the remarkable identity, we see a common, right?
Yes.
Okay, here what do you see?
A common.
Which is a 3. Here, it's
Nothing.
finished, okay? So let's work in the first 2. In the first parenthesis, what do we take common?
6 common.
6
Into
into
x squared
yes,
minus 2x
minus 2x
plus 1
yes. In the second one, we take 3 into
x squared minus 1
and the last part stays as it is. Okay? Now, the first one now is a,
remarkable identity,
which is x minus 1, yes, plus the 3. The second one is also the third remarkable identity, Muhammad. Be with us.
minus 1 into x plus 1.
Minus, sorry, this is no, minus x minus 1 into 2x plus 1 is equal to 0. Now what do you see a common factor?
X minus 1.
X minus 1, and we open a big parenthesis.
6 into x minus 1.
Yes.
Plus 3 into x plus 1.
Yes.
Minus into 2x plus 1.
2x plus 1
is equal to 0.
Is equal to 0. Now we should get rid of the second. Yes.
6x minus 6 plus 3x plus 3 minus 2x minus 1 is equal to
Minus
1
1 is equal to 0. Now we should reduce the inside. 6x plus 3x
9x
minus 2x
7x
7x minus 6 plus 3
minus 3
minus 1
minus 4
minus 4 is equal to 0. How many solutions? The first one,
x minus 1 equals 0.
then x is equal to 1. This is the first solution. The second solution,
7x minus 4 is equal to 0. 7x equals 4. X equals 4 over 7.
thank you. This is the second solution. Okay? Now the second one. Yes, Badia, start solving the second one. What do you see, Badia, in the first part of the second one? The one there, x squared minus 4x plus x minus 4, all of it squared is equal to 0. In the first one, no, we don't have a remarkable identity. We have x squared minus 4x. We have common, right? We have a common, which is x into x minus 4 plus x minus 4 squared is equal to 0. Now what do you have common? We take x minus 4 common. X plus x minus 4 is equal to 0. Yes, Badia?
X plus x minus 4.
X plus x minus 4 equals 0.
Yes. X plus x,
2x.
2x minus 4 is equal to 0. We have two solutions.
X minus 4.
Then x equal, this is the first solution,
2x minus 4.
is equal to 0. Then 2x is equal to 4.
X equals 4. 2. X equals 2.
This is the second solution. Okay? Now the third equation, Hassan. In the first part, do you have anything?
No.
Look at the second part. Do you have anything in the second part? What do you have? Inside the parentheses. What do you have here inside the parentheses? which is 2. Do you have here something inside the parentheses? Common, which is 3 or minus 3? Minus 3, yes. Now we start. So we write the first part as it is. Yes, Hassan?
X minus 3, 2x plus 5 plus 2 x minus 3
We take a common 2, yes.
Plus
Now what do we take common?
plus 3
We take common minus 3, and outside we have minus, it becomes plus 3, and we shift.
x plus 1
x
Minus 3, right?
into x plus 1.
We change places, right? Yes. Now what do you have common? X minus 3, and we open a big parenthesis.
plus 2 into
3x minus 1 plus 3 into x plus 1 is equal to 0.
Yes. Now reduce the inside.
2x plus 5
Yes.
plus 6x plus 3
Minus 2
minus 2
plus 3x plus 3 is equal to 0.
Is equal to 0, yes. Now 2x plus 6x
8x
plus 3x
11x
plus 5 minus 2 plus 3.
plus 6.
How many solutions do we have? The first one.
x minus 3 equals 0 x equal to
This is the first solution. The second solution.
11x plus 6
Then 11x is equal to.
Minus 6.
Then x is equal to minus 6 over. This is the second solution. Okay. We continue solving equations. Yes, Dana. Look at the first part of the equation. What do you have?
Remarkable identity.
Is it a remarkable identity, or it looks like to be a remarkable identity? What should we do?
Take common
Minus, and we open parentheses. We write. We don't make it directly a remarkable identity. We write it first, Hassan, okay? Yes?
plus 4x minus 4x
Yes.
minus plus 4
Plus 4, yes. And we bring the second one to the first part.
into x minus 2.
Now make it a remarkable identity. X minus 2, all of it. Yes, and we write the next part as it is. Now what do you have common, Dana?
X minus 2.
Yes, x minus 2 into, what do you still have? Minus into x minus 2,
Minus 3x plus 5
yes, is equal to 0. Now x minus 2,
minus x
yes,
plus 2 minus 3x minus 5
is equal to 0. Minus x minus 3x,
minus 4x
2 minus 5.
minus 3
How many solutions do you have? 2.
x minus 2 is equal to 0.
Then x equal,
2
this is the first solution. The second one,
minus 4x minus 3 is equal to 0. Minus 4x is equal to 3. X is equal to 3 over minus 4.
good. Okay. Now we have Ali, 5x squared plus 4x plus 3 equal 4x.
We bring 5x squared plus 4x plus 3 minus 4x equals 0. 5x squared.
4x minus 4x cancel each other. We have 5x squared plus 3 is equal to 0. This is impossible, right? We don't have any value for x that gives me this equation equal to 0, so we write no solution. Right. Now we will solve inequalities with less than and greater than. Start, Ala, with the first one.
2x plus 6
Yes.
minus 5x is less than
We bring the next part, plus 7x plus 2 is less than 0. Now, 2x minus 5x
minus 3x
plus 7x
10x
minus 3x plus 7x. Minus 3 plus 7. 4x. Plus 6 plus 2 plus 8 is less than 0. Now we write 4x. We divide both parts by, divide by 4. So we get, we are dividing by a positive. The sign is preserved. So x less than minus 8 over x less than minus 2. This is the solution. Now the second one. Yes, Badia? All the x's on a side.
X over 5.
X over 5.
Minus plus 7. Plus 2x over 15.
Over 15. Greater than or equal.
1 plus 7 over 15.
Now what do we take as a common factor?
15.
15 over 5
3
times x. 3x. 15 over 15
1
times 2x.
2x.
Greater than or equal. What do you take?
3. 15.
15 over 1. 15 times 1. 15. 15 over 3. 15 over 3. 5 times 7. 35. Yes. Now 3x plus 2x. 5x over 15 greater than or equal 15 plus 35. 50 over 15. Sorry. Now we write 5x greater than or equal 50. Then we divide both parts by 50 over 5. Then x is greater than or equal to 10. Yes, Hassan, solve this one.
Minus 7x minus 2 plus 5 greater than minus 4x plus 3.
All the x's on a side.
Minus 7x plus 4x
Greater than 3 plus 2 minus 5. Minus 7 plus 4 minus 3x greater than 0. We divide both parts by minus 3. If we divide by minus 3, the sign is reverse, so x is less than 0. The last one, Selena.
3x squared minus x plus 4 is less than or equal 3x squared minus 6.
Yes, all the x's on a side.
3x squared minus x minus 3x squared is less than or equal minus 6 minus 4.
3x squared minus 3x squared, they cancel each other. Minus x less than or equal.
Minus 10.
We divide both parts by minus 1. So x is greater than or equal 10. This is the solution. Now question number 4. We should draw a triangle ABC such that BC equal 5 centimeter, angle ABC equal 40 degrees, angle ACB equal 60 degrees. How do we draw this triangle? Who can tell me how we draw this triangle? We draw any side BC, 5 centimeter. We assign the angle B 40 degrees. We assign the angle C 60 degrees. Where they intersect is the third vertex. So we get triangle ABC. We should draw AM, the median relative to BC. I repeat, as I say always, in the geometry we should put marks, okay? When we draw the median AM, we know that M will be the midpoint of whom? Of BC. So we should put a mark that BM is equal to what? To MC, okay? Let O be the midpoint of AM. When we assign O the midpoint of AM, we write OA is equal to OM. BO, we join BO, it will cut AC at D. Okay, D is any point on AC. So let E be the midpoint of DC. Also, we put a sign that DE is equal to EC because this will be useful in our solution, okay? The first part, we should prove that the quadrilateral BMED is a trapezoid. Look at the quadrilateral BMED. We should prove that this is a trapezoid. To prove a quadrilateral is a trapezoid, we should prove that it has two parallel sides, okay?
Yes.
This red line and this red line are in which triangle?
DBC.
DBC. What is E?
The midpoint
The
of
midpoint of BC, right?
Yes.
What is M?
The midpoint
The
of
midpoint
BC.
of BC. So what can we say about ME?
It is a mid-segment and it is
triangle
parallel.
CDB. It's equal to half
Half
the
the
hypotenuse and
hypotenuse.
half the opposite side and equals its half and parallel. Okay. Then ME will be parallel to BD. Then the quadrilateral is
Trapezoid.
this is the solution. So in triangle BDC, E is the midpoint of DC, M is the midpoint of BC. From these two, we get ME is the median segment, ME is parallel to BD and equals its half, then the quadrilateral is a trapezoid. Okay?
Okay.
Now, we should prove that D is the midpoint of AE. How can we prove that D is the midpoint of AE? How? D is the midpoint of AE.
Miss ME is parallel to
Let's
BC.
look at this one. Which one? Let's look at triangle AEM. What is E?
Midpoint of BC.
The midpoint of DC, right?
Yes.
We have OD parallel to
E and
ME, then and O is the midpoint of AM in this triangle AMC. Do you see the triangle?
Yes.
ME is parallel to OD and O is the midpoint of AM. So D will be the midpoint of AE. Okay? This is the inverse of the mid-segment theorem. So in triangle AME, we have O is the midpoint of AM and ME is parallel to OD. We proved it in the part 1. Then D will be the midpoint of AE. This is the inverse of the mid-segment theorem, okay? How can we deduce that CD is equal to 2AE? Yes, Selena.
Since D is the midpoint of AE,
Yes.
then AD is equal to DE.
Right, and E is the midpoint of DC, then DE is equal to EC.
Then CD is equal to 2AD.
Right, yes, this is correct. So E is the midpoint of DC, then ED is equal to EC. D is the midpoint of AE, we proved it. Then AD is equal to DE. Then CD is equal to 2AD. So how can we prove that OD is equal to 1 over 4 BD? As Selena said, we have ME equals half BD and OD is equal to half ME. We substitute and we get OD is equal to 1 over 4 BD. Now question number 5, we should construct an isosceles triangle EFG. Always when I say isosceles triangle, the first thing that comes to your mind is how to specify the equal sides and the equal angles. We should specify the equal sides and the equal angles, okay? So here the equal sides are if E is the vertex, who are the equal sides? EF and EG. Who are the equal angles?
Angle G and angle F.
EGF is equal to EFG and each one will be equal to 45 degrees. We should find the missing angles of triangle EFG. If each one of these two angles is 45, what remains for angle E? 90 degrees. So what's the nature of triangle EFG? It is right isosceles, right? Because it has a right angle, isosceles because it has two equal angles. Now we should find EF, the measure of EF. How can we find the measure of EF? We only have the measure of FG equal 5 centimeter. What do we use here to find the measure of EF? What do we know? FG is equal A radical 2. Okay? Yes?
GF equal EF radical 2.
In the right isosceles triangle here, we can solve it in two ways. We can directly apply Pythagorean theorem and we substitute, or as Ala is saying, FG is the hypotenuse, right?
Yes.
In the right isosceles triangle, we have taken a rule which is FG is equal to A radical 2. A is the side. How much is FG? 5 is equal to A radical 2, then A is equal to 5 over radical 2. This is directly, okay? Or we can solve it using Pythagorean theorem, which is this, okay? So EF is equal to 5 radical 2. The first one is direct on the rule, the second one using Pythagorean theorem.